Alright, so I just want to talk about this question here. It's a bit tough, but if you just go step by step, it all works out pretty well. Basically, we've got two different cars. One is depreciating using the diminishing value method. You can see it's decreasing by 4% each year. And one is depreciating using straight line. It's depreciating by $3,000 a year. And the question is, how long will it take for both cars to have the same value? So first step here is to sort of write out your formula. The diminishing value is A equals P1 minus I to the power of N. And I can put some numbers in there. A equals 40,000 times 1 minus 0.04 to the power of N. Now we don't know A and we don't know N, but that's okay. We can work around that. Let's look at this second bit here. A $60,000 car depreciates by $3,000 a year. Now that's now I could use salvage value here, but I'm just going to use A. You'll see why in a minute. A equals the initial value minus the depreciation times the time in years. Now that means that A is equal to the initial value, which is 60,000, minus D, which is 3,000, to the power of N, which we don't know. Okay, so both in this equation here and this equation here, we don't know A and we don't know N. Now, what I want to do, I'll show you. I want to graph this on my graphics calculator. But unfortunately, I can't do that with A and N. So I have to use Y and X. So I just need to rewrite these equations. Y equals 40,000. 1 minus 0.04 is 0.96 to the power of X. Okay, and this equation as well. Y equals 60,000 minus 3,000 times X. So now my equations are in Y and X, which the graphics calculator can deal with. So take your graphics calculator, you've done this before, and open up the graphing mode. Now I'm going to type in my first equation here, make sure that it says Y at the front here. Y equals 40,000 times times 0.96 to the power of, and then use the X button right there, X. Okay, and I'm going to type in my second equation here. Y equals 60,000 minus 3,000 times X. Now, I just want everyone to see this really well, so I'm going to change my style on my second equation to be a dotted line. So don't forget, the straight line is the depreciating graph, and the dotted line is the straight line graph. Okay, so the dotted line is a straight line, and the curved line here, sorry, the dotted line is the straight line depreciation, and this line here is the diminishing value. And you can see there is a point where those two lines meet, and that's what our question is asking. How long will it take for both cars to have the same value? Now, if you're not really understanding what this graph means, the y-axis here is our A value. So it's the value of the cars. Okay, and you can see the value of both cars is going down. Okay, this one's going down in a straight line, this one's sort of curving. And the x-axis here, that's our time in years. Okay, so once you've done that, be careful here. The next step is to press G-solve. That's graphical solve, F5. And then, oops, sorry, it's on the first menu here. Maybe I'll just show you that again. G-solve, and then this ISCT, that stands for intersect, where the two lines meet. Alright, and there's our answer. Now, to interpret this answer, X was your number of years. So X is 11.745 years. So after 11.745 years, these two cars will be at the same value. Now our Y is the value of the cars. So the value of these two cars after 11.745 years, the value of both cars will be $24,764.76. So that's what this whole thing means. That's where they're meeting. Okay, I'm just going to write my answer here. 11.745 years. Okay, bring that calculator back. The only other problem you might have is that when I opened that up, my two graphs showed up really well and I could see where they met. You might have problems with that. So you need to familiarize yourself with this, which is the view window. Just press F3 then. Now, when you do this, make sure that your X value and your X minimum and your Y minimums are just a little bit negative. So like -1 or -10. I've made the Y minimum -200, just because the Y values are much larger. And then you just need to make sure that your X maximum, that's how big your X axis is going to be, will cover the amount of time that you need to cover. And you need to make sure that your Y maximum is higher than the highest value of your car. So one of these cars is worth 60,000, so I made my Y maximum 70,000. And then that gives you a really nice view of everything that's happening in that graph. Okay, so that's using a graphing calculator to find where two lines, in this case two depreciation lines, meet, and when two cars will have the same, or two things, whatever they might be, will have the same value. All right, thanks guys.